Jacqueline, thanks for sending another question. We're going to be graphing the function you sent us here. And to do that, we're going to go through 3 steps here. The first thing we're going to do is figure out what family of functions we're in. Meaning, let's look at the leading degree of x here. It looks like we have x to the third. We know that the x to the third function looks like a little squiggly. So our graph in general is going to look like a little squiggly. So the next thing we're going to look at is our local behavior. That sounds kind of complicated, but all it means is we're looking at what the graph is doing as we're close to the origin. So as you can see, I've just plugged in I've chosen a few points close to the origin here, -1, 0, and 1, and we're just going to plug those into our function. So if you plug in -1, you'll see that we end up with 0. If you plug in 0, we end up with a y-intercept. That's y equals 3. And if you plug in 1, we end up with 6. So we're just going to go ahead and graph those points on our graph. -1, 0, 0, 3, and 1, 1, 2, 3, 4, 5, 6. And we're going to connect the inside in between these points with our squiggly shape. So that's kind of what's going on as we're close to the origin. Now let's figure out our end behavior. For our end behavior, it just means what is the graph doing once we get past these points. To do that, we're going to look at our leading coefficient, which again sounds kind of complicated, but what it means is we're looking at the number in front of the x to the third. Is it positive or is it negative? If it's positive, our graph will be doing what we expect it to do if it's x to the third. It'll go down, down, down here, and up, up, up here. If it's negative, we're going to flip it upside down, and it's going to be doing the opposite. It looks like the number in front of x to the third is just 1, so it's positive. So our graph is doing what we expect it to do. It's going down, down, down as we go towards negative x, and it's going up, up, up as we go towards positive x. And that is what the graph looks like. Thanks again for your question, Jacqueline, and I look forward to answering more of your questions using SnapMath in the future.